take over these sessions. Welcome, madam.
Thank you, sir. Sir, am I audible?
Yes, ma'am. Yes, madam.
Thank you, sir. So, good morning, everyone. Already, sir introduced me, so we will enter into session directly. So, is it clear with the line and all? Jagadeesan, sir?
Yes, sir. Yes, sir, madam. Please clear your voice.
Thank you, sir. So, today, first is we are going to start with the concept called Introduction to Machine Learning part. Okay. So, first, let us start. 1 second. My screen is visible, sir? No. Okay.
Visible. Sorry, it is visible, madam.
Yes, sir. Yes, I'm trying for the annotation.
Okay. Okay.
So today we are going to start with the first thing called Introduction to Machine Learning. Okay. Second, the slide is not moving. So slide is changing.
Yes, madam.
Clear, madam.
Yeah, okay. Thank you. Okay. If I start annotating, it's not at all moving with the slide actually, sir.
Now check, madam.
So if I annotate, no, it's not moving the slide. See, again, it's stopped. Okay. Okay.
Now it is changing.
Yeah, okay, sir. So let us start with the first thing. Even though we are faculty, whether it is a student or everyone, we are having a slight confusion with this terminologies because if you see in depth, it's almost synonyms to each other, but there is always a minute difference in it, right? So we shall start our session with this difference. So first of all, what is AI, ML and DL? We know the definitions already, artificial intelligence, machine learning, deep learning and all. I wish to give you just a difference between these terminologies. Let us look into the AI. Artificial intelligence, you can consider artificial intelligence, it's simply I just want to make a machine to think like human. So even I'm a kind of person, yeah, human, I don't know what is the next word I'm going to tell because whatever comes to my mind, I'm randomly telling the things. I'm not predefined anything. This is how I want to tell all those things I didn't pre-plan. So what is, I know the concept, what are the words I want to put to deliver my content, I can decide on my own randomly. On that case, how I can make a machine to think like human. It's not that much easy task, right? Even one or two technique is not sufficient to make my machine to think like human. Right there, when you want to make a machine to think like human, that is called artificial intelligence. The one particular technology is not sufficient. If you see in depth of AI, hope yesterday Sarah has discussed about AI concept, right? It includes with n number of concepts like machine learning and data science, big data analytics, image processing, and what are all the computer science specialization department you have seen. All those technologies will be taken part in that artificial intelligence technique. So it is a vast area, very vast area. Okay, so I told artificial intelligence includes with many number of techniques and technologies and concepts in it. One of the thing is the most important thing I can tell, that is called machine learning. So let us come to the point, what is machine learning? So here the machine learning is nothing but I am going to make my machine to learn from the past things. For example, I use it to train my machine as, see, this is apple. I will train my machine. What is the shape of apple? What is the color? All those things I can train. Once I train my machine for a particular input, after the training part and all, in future, whenever I give an apple to my machine, it will predict, yeah, you have given apple to me. That it can predict. That is the capability of machine learning. But if you try to give orange to that machine, it will tell, I don't know it is. Because it is trained for the purpose of only apple. You can't expect from the machine like it should predict for orange. So machine learning is nothing but I am trying to make my machine to learn from the past. Based upon the past learning experience, it will apply its knowledge in future and predict the things. You know this point, only it will predict the things. You whatever the thing you go, you can't tell 100%. It's everything comes with the prediction only. Okay, then next point is, then machine learning includes many things. It's I will tell you when we are discussing about neural network, I will tell you that part. See, machine learning is simply a one layer prediction. Like I will extract the features, I will match with the things, and I will go for the output. But there are a few kind of things I can't simply make a decision in a single layer. Example, handwriting. If you ask me to put 8 number, I will put in my style. If you can put it in your style. So you can't expect all the people will write 8 in the same way, right? And that case, by splitting a one layer of predicting, definitely it's not sufficient. So I want to analyze the data to the depth, then only I can come to a certain conclusion whether the data is 8 or not. Okay, so that is called as deep learning. So here it is nothing but I just want to do a detailed analysis of given data. That is called deep learning. See, mostly why you are using deep learning now? I just want to increase the accuracy in my prediction. I can use the deep learning. One of the most important terminology that you have heard every now and then is neural network concept, that we are going to discuss in our today's session anyway. We will come to that point later. So this is the basic difference between AI, ML and DL. Okay, hope I am clear to you. We will move to the session that is nothing but machine learning. Already I told, right, there are n number of definitions available for machine learning. These two are the most famous and most apt definition for machine learning. So the first one is, the machine learning is science of getting computers to act without being explicitly programmed. You may get wondered how it can work without explicitly programmed. Just you are making your machine to train by itself to define what is the program is all about. You may feel a little bit confused. When we are going to the next slide, you will get clarity. So this definition is defined by Andrew Ng. So the next is the most famous and most appropriate definition for machine learning, I can tell you. See, you see here, there are three terminologies in machine learning. What is that? Performance, task, experience. This is a definition given by Tom Mitchell. What it is, I can improve the performance of the task with the experience. So this is nothing but how much you are making your machine to learn, that much perfection you can expect from your machine. That is what the simple meaning of this definition. More I am training, the best I can get the prediction at the end. So this is what they are telling. You are having a certain task in hand. You want the better performance. How I can achieve the better performance with the more experience in that particular task. Okay. So this is the definition of my machine learning. See, I told one word here, hope you have noted, right? Explicitly programmed, without being explicitly programmed, how it is possible. So this is the difference between your traditional programming and machine learning. So when you come to the traditional programming, you are going to lab C programming lab or Python programming, Java programming, whatever you do, what you will do, first I am giving a program for addition of two numbers, for example. What you will do? You will write a program for addition of two numbers. Right, after completing the program, you will give two inputs to the computer like 1, 2. I will get the output as 1 plus 2 is nothing but 3. I can get it as the output. But in machine learning, it will happen in reverse. That's what they told, without being explicit program. Here, what I'm going to do is, I will give the input 1, 2. I will see the output as 3. So both the things I will give it to the machine. Input is 1, 2, output is 3. So now my machine is going to learn from this input to output. If I am giving the input is 1, 2, the output is 3. Probably what kind of operation it is? Definitely plus operation. Okay, so there is a certain confusion to it. For example, I am giving a data 1, 1 here. Output will be 1 I am getting. Okay, and that case 1 star 1 is also 1. 1 divided by 1 is also 1. Here I am getting a confusion. That's what they told in a second definition. If you want to get a perfect or improved performance, what you want to do? You have to do more experience on it. So what you have to do? Instead of taking one example 1, 1 by 1, here I can go with the next example 6, 2. Here I am getting the output is 3. So which is nothing but division operation. How it is possible? When you are taking a more number of input, I can get, so what kind of operation it is. So from the input and output, it is finding what is the background program between, what is the background logic behind this input and output. So this is how my machine learning is learning for predicting the things. So that's what my definition now. The machine learning is science of getting computers to act without being explicitly programmed. And here I have explained you how I can increase the performance by giving more experience to the given task. Okay, so this is the basic difference between your traditional programming and machine learning part. So now I will, this is the, I can tell you a kind of pictorial representation how the machine learning is working. What I told already, I use it to give the input for my machine learning is information, that is nothing but your input data along with the answers associated with that input data. By providing these two things, I can get output, that is nothing but what is the mathematical model or what is the concept behind this input and output. That only I have to predict over here. Okay, that can be a kind of relationships, or it can be sometimes patterns, dependencies, hidden structure. There are n number of algorithms and techniques involved in it. That's what we are going to discuss in our today's session. Okay, so now let us come to the next point, that is what are the different types of machine learnings available. So there are already earlier days it was one more type is also there, supervised, semi-supervised, unsupervised reinforcement. But nowadays semi-supervised is not at all used at anywhere. So these three are the currently usable models of machine learning. So supervised, unsupervised, reinforcement. So supervised is nothing but task driven, unsupervised is data driven, reinforcement is according to the environment it will learn. So we will go to the slide so you can understand more. Let us start with the supervised learning part. Before we are seeing this theoretical part, I just want to show you the analogy for this. So here what will happen now, as per the name suggests, here one thing will be there, like what is your predefined input, what is your desired output, and for this input I may give a certain supervisor. They will tell what is correct, what is wrong to you each and every time. So that is called supervised learning here. Okay, so what it will do is, while I'm starting my process itself, I will give my computer, this is the apple. I will tell my computer, I will give the image of the computer, sorry, image of the apple. At the same time, I will tell the computer, this is called as apple. So I have a training image as well as what is the desired output for that image. Both the thing I am giving to my computer so that it is processing, and finally it is finding a certain trained model from it. So you see here, if you take apple as an example, if you see local apple, it will be very small in size. If you see a Kashmir apple, it will be in different size. There are a kind of apple that is looks like even tomato shape, right? Even there are a few apples in green color as well. So what you want to do is, you want to train more number of things. So when you are training, what are the things it will consider to learn now? It will find what is the shape of it, what is the color of it, and what is the height, what is the width, what is the different dimensions. Like that, it will take each and every attribute into a consideration. Then it will store all those things into a trained model. So this is how it will work in a supervised learning. What I will do, I already told you, right? I will give input as well as output. Input is not a single image. I may give a bulk of data to learn. When I am giving a more number of input, then final prediction will be very good. Suppose you have trained your machine only for simple apple. Okay, suppose you are after training, you are thinking like, okay, I train my machine for predicting apple. Now I will give the apple image. Let us see whether it is predicting or not. You are giving a local apple to you because the similar apple attributes, the dimensions, everything, it won't suit for the local apple because it comes in a different shapes and all. Even color is also looks different. It will be very dark in color, but if you see here, the color will be little bit whitish and all. So that kind of predictions or accuracy, if you want to increase, you have to train your machine with the more number of different types of apple, like even colors also. See here I have trained for grid, but even though I'm giving green, it is finding. So it means that green apple also I have taken into a raw data. I have trained my model in such a way. Okay, so this is called as a supervised learning. Okay, after that, once I got my trained model, after that, whenever I am giving a certain input to my trained model, it will predict, yeah, it is an apple. But if you are trying to give some other, definitely it won't accept. Okay, let us come back to the theory part. The program is trained on a predefined set of training examples, which then facilitate its ability to reach an accurate conclusion when a given new data. Hope you understood, right? That's what we have done. We are giving a certain set of raw input with the desired output to the training model. It is delivering a certain trained model. Whenever I am giving a new data to it, it is predicting what is the given input is all about. Okay, and similarly, there are n number of methods involved in it. Regression, classification, and decision tree are the most famous supervised learning algorithms. Okay, you see here, if you see in machine learning framework, I will give what is x, and you know, right, y is equal to f of x is a certain model, y is the output, x is the input, f is the prediction function between the y and x. Here it goes in a reverse model, you know, right? What will happen? I will give x and y to the my machine learning part. It has to find what is the f. That is what we are doing, right? I will give what is input, what is output, but it should find what is the concept behind this input and output. It is finding, right? This is called training. Actually, machine learning is divided into two major phases. One is the training, another one is testing. So during the training phase, y and x will be taken as the input. It will predict f as the output. When I am going for the test phase, I will give a input x to the predicted function f in the previous training session. So it could find what is the exact y. You see, if you are getting 100, I don't know if people are aware or not, there is a 80-20 rule in all these kind of features. What is the 80-20 rule? Suppose I am getting 100 training data set. Here I told now, I am going to get training data set. Suppose here I am taking 100 examples. I will take first 80 examples in the method of training phase. What is training phase? I will give x and y as the input. I will get f as the output. So 80 will be adapted for the training model. 20 will be given for the testing model. So what will happen with the remaining 20? It will give the input for the predicted function f. It will check whether y is predicted correctly or not. If it is not, again, it will learn from its mistake and it will update in the trained model, so that when I'm going for the real testing, it will give me the correct answer. Okay, so this is the thing called machine learning framework. You see here, see, this is what we have shown, right? Regression, classification, decision tree. So one example here I have given is classification. What I am giving, the training images contains this many images. What are they? Many fruits are grouped here. While I am training these things, here I am giving a training labels. That is nothing but this is called supervised learning. I am giving input to them. See, if something is here, this is apple, banana, orange. All those things it will be given as a training labels. What it will do? First, it will extract the images from this part and it will extract its features or attributes from it, and it will match with the training labels. Whatever is matching, accordingly, it will give you the learned model. So like this only, my machine learning used to train the things. This is what we have shown in the first thing. Under the supervisor, the input training set is going to provide you a learned model. Okay, so this is what the thing. Okay, you see here, I can give a test image. What it will do, immediately it will find this feature. You see here, the light color apple is there. It will extract all its features and it will give its feature to learned model that it learned from the previous session. And what it will do is it will predict it is an apple. Okay, you see here my images, it is not actually plum, it is actually orange. But what happened here, I try to, because this particular image may not be trained by my model, so it is predicting in a wrong way, it is a plum. See, you see here, it is extracting its features like small in color, all those things it is extracting. It is applying that learn model, finally it is predicting it is cherry. So it is not the correct prediction because I didn't uh, train my model for this particular image, so definitely it won't work. So this is how you have to do the things. Suppose I think if most of you people have heard about predicting house prices. This is the most famous example of data machine learning part, that too especially in supervised learning, right? So here what I will do is, here the regression type, what I will do now, so based upon the previous data I have been collected, I use it to frame a certain framework. Based on the framework, later on, I will predict a certain thing. For example, if you belongs to a Bangalore, if you are going to Bangalore, you just want to take one home for 400 square feet, for example, in this, upon that, in that 400 square feet, I want 1 or 2 bedrooms. Okay, that too you have fixed a certain location in the Bangalore, in that location only one house. But before you are going to the real-time searching, you just want to predict what can be the house rent in that area that you want to think. If you check in net and all, it is coming, right? This can be a approximate price in that area to get a house and all. How it is coming? So what they are doing is, earlier they are going and collecting the literal data from the field. I mean 400 square feet, one house is there, 2 bedroom house, all the amenities are available. Based on that, what is the rent they are collecting, like that they have the certain data set. According to that data set, they are taking, here I have taken only 2 parameter. One is the house size in meters and another one is the price in dollar. So based on these two features, I have I have collected a certain data. For the data we have drawn a certain graph. So what is happening here, suppose here 100 square feet house, the house may be rented or ranges from $10 to $15. Why it is? Because based upon the amenities or based upon the location of the area and which floor it depends upon. So there are n number of features in it, right? It's not about only the square feet. It's about the amenities they are providing. It's about the location of the house and which floor it is. That also matters, right? So like I have a n number of house features along with the house size. Considering all those things, I am going to give a certain kind of comparison graph for the already existing data. Suppose I am new to Bangalore. These things already I have done using a machine learning model. I have given house size and price also, and it learned from the various features. It has drawn one particular graph. So what's happening now? I am entered into new person to Bangalore. I just want to check in electronic city. I want a house of 400 square feet in ground floor with all the parking facility, all security guards I want. By giving all those features, I can get, see this part maybe the lowest price I can get for $18. The highest may be a $30. On that case, there is some normalization line. These are all includes with the mathematical concept. So what it is, bar the average of, I may get house around $20 for the features what I am looking for. So always I am telling the whatever the terminology I can use in AI, ML, DL, all this concept, it's always tells with the thing predicted. It never and ever tells you the word concluded that. Because if suppose I am a kind of researcher, I have concluded, I have predicted my model with the 0.80 accuracy. If you are the one ready to prove for that same data set with 0.81 accuracy, you are provided with the doctorate. Even doctorate degree they are ready to give. Because that is the thing of predicting the things. You can't expect a machine to predict 100%. It's never possible ever. Okay, so that's why I'm just giving a certain approximate thing around $20. You may get a house according to your features, whatever you want in that particular location. It may go plus or minus $5. It's, you can't give a guarantee to that. But instead of going blankly to that area, now you got some idea. Okay, if around $20 to $25, I may get one good house in that area. What I'm looking for the features also. Okay, so this is called as the regression model. Okay, so the next model you can take it is classification model. So here it is that iris flower. Hope you have heard about the iris flower, right? There are three varieties are available in the iris flower: versicolor, Virginia, and setosa. These are the three different types. So what are the things in it now? If you see all those three flowers, their petal length and petal width are entirely different. See, one is very length petal, another one is with is very small, another one is with is so very less and broad, like that. If you see all three, all are iris flowers only, but as based upon the family name, that petal width and length will vary. So now how I can divide the iris flower is based upon the what is the petal length and width. Okay, so what I will do is based upon the petal length and width, I use it to group my things into a, sorry, group into a different variety so that I can differentiate easily what that is belongs to iris setosa or iris versicolor and iris virginia. If you see there are some overlapping, because if you see this is a natural thing, right? You can't expect all the time versicolor will be in the same width and height. There can be a small, little bit small or little bit high. There can be overlapping, but if you see very odd number of overlapping only will be there. Very not huge number of overlappings will not come. Okay, so this is how, by considering my petal width and petal length, I'm just going to classify my data into a different types of iris flowers. So what is the thing I'm taking here is length and width of the thing. Okay, so this is called as classification. Hope I am clear how we are calculating the, how we are predicting the things under supervised learning. Okay, next is the unsupervised learning. So here unsupervised learning, it is just opposite to supervised learning. Here no one will be there. As usual, we will go with the analogy first. Here I will give the raw input to the data. Already I have told you here, right? If I am giving apple, I use it to tell you, see, this is apple, you learn. Like that, I use it to instruct my machine to learn. But you see, I'm not giving anything here. I'm not going to give any output to my training model, right? I'm not going to give any training data set also. What I will do is I will give a raw set of input to my machine. What it will do, it will interpret itself. It will do all type of interpretation among the fruits. If you see, I am giving all these things, it will find the matching between these two things. So where and all matched things are there, though, all those things will be considered into a single group. For example, one green apple, one red apple, and red apple also in different varieties you are giving. Anyway, orange mango undal will not suits to the features of apple, right? Whether it is a bigger or smaller in size, the apple features and mango features definitely won't suit. So what will happen, all those similar categories, it will divide its attributes, all those things it will extract, and it will features and all it will match up. Then it will finally coming to a conclusion. So these kind of things will be one category. Don't know it is the apple also, it will predict it is a kind of this fruit, it is a kind of this fruit, and this is a kind of this fruit. If you are expecting, you want it is an apple, it won't predict it is an apple. When you are giving a certain thing, it will predict from the past, yeah, this is the thing, because you didn't make your machine to learn this is an apple. You made your machine to learn this is kind of shape is belongs to this group. Okay, so this is called as unsupervised learning. There is no training labels will be provided. Based upon the given data set, it can be learned. Suppose you have associated apple in its feature, it may predict. But if you are giving only image to that part, it is learned for only that image. It will give you only that image as the one thing. And it is doing the all those things by correlating its maximum features. You see here, even though I have given another one kind of apple, it will correlate with its feature, because that feature will not be exactly matched to this apple, and it's try to correlate with other things like these two features also, which is having the most reliable, most accurate correlation with each other. That things will be categorized into one apple. You got it right. So this is how unsupervised learning will happen. So there is no training examples used in this process. Instead, the system is given a set of data and tasked with finding patterns and correlations therein. So that's how it is finding the things. Okay, so the best and foremost example is nothing but clustering, and finally it will come up with the neural network that we will discuss in next session actually. So next, the exam I told right that best example for unsupervised learning is the clustering part. You see, you are searching in news and all, right? When the news is coming, that news will not come as the bundle. If you see in category, no one is classifying that this is belongs to sport, this is a world news, this is a local news. If you are searching in your place, for example, if you are searching in Andhra, so 1 year Chittoor, I am searching the Chittoor day based district news will come. How it is happening? Based upon my location, my local news are coming, and based upon the category, it is clustering by itself to deliver the content to the user in a better way. Okay, all the similar news, for example, it can be athlete or it can be a cricket or whatever the things related to the sports, that everything is grouped under a single thing. You are searching in India, but you are all the things other than India will be comes under the world news, BBC news. If you see, all the things will be comes under all major newses they will cover. So how it is possible? Your data is like it's not actually how it is, but it is arranged as per the features involved in it. What is the feature involved here? The commonality between all these news is that is nothing but different varieties of sports. Okay, if you see here, the different varieties of information related to science. If some information I'm getting from NASA, or getting about ISRO, or something I am getting information about what we can satellite launching, all those things will be comes under a science related news. Okay, so this is how my documents are clustered into a different group based upon the common feature involved in it. Okay, this I'm not going to tell this is the world news and all, it's automatically doing. So this is called as unsupervised learning. This is the one of the best example. Then third method, if you ask me, all these three methods, which one is the intelligent method now, or which is the most interesting machine learning method? I can tell you it is a reinforcement learning. You know what is reinforcement learning is? There is no such thing called training or explicit supervised learning or unsupervised training. Nothing will be here. Here what it will do is machine will learn from its experience. Okay, so the best example we have ever experienced, if you are seeing now, online chess and sudoku, all those things we are sorry, on sudoku, online chess and all we are doing, right? If you are moving one coin, opposite also machine automatically moving another coin. If you are really good enough in chess only, you can win the machine, else you can't. How it is possible? What it will do, you know, once it is starting its gaming, no, it will start learn from its experience. Actually, first it will move this part, then opposite also it will make a move, then it will do all the probability, and finally it will see whether it is a win. If it is won the game, what it will do, it will be given with the reward. So what is the reward? Which means that yeah, it is a successful completion. I can store that way of move in my success story. Suppose after that move, I got failed, or I lose the game at the end. What I will do, there is a punishment, which is nothing but that action not at all succeeded. So I should not repeat this process. So it will not be added in my success story. So whatever the data stored in the success story will be, make it as the experience. Then that will provide me the trained model at the end. So after that, whenever I'm giving certain thing, it automatically check with my trained model, it will give me the output. So here, if I am giving a certain apple, that agent will find it is the apple or not. If it is apple now, that it is really correct, it will be rewarded. So it will be stored in a model train. And if I am wrong, prediction will be given with a certain punishment. So it will not be added in a model train. So this is how I learn from my experience. This is called as the reinforcement learning. There are n number of methods involved in this. That is criterion of optimality, brute force, Monte Carlo methods. All the methods are example of reinforcement method learning. And the best example is gaming and all. The best example for reinforcement learning that we are using. So this is a simple analogy for reinforcement learning concept. You see here, when you are giving food to your dog, definitely it will get salivation. This is a natural process, right? Without any condition, it is getting automatically simulated because it is tuned for it. The next time, without food, you are making your dog by giving a bell, you are checking whether the salivation is coming or not. Definitely it won't, because dog don't know anything about this, right? Because bell sound is kind of sound to it, right? But what you are doing in later on, you are, whenever you are ringing a bell, you are giving a food to dog. You are making your dog to practice in such a way. So after that, whenever even you are coming with a simple bell sound also, your dog will get salivation, because your dog knows that when the bell rings, by default that owner is going to feed him with the certain food, because it is the kind of practice it trained for. How it is possible, it learned from its mistake. First and all, it's not giving, so which means that later on I'm training my machine with that particular status. Then after that, whenever even simply I'm doing also, it getting simulated. So the same thing we are applying in reinforcement learning also. Whenever you are doing a certain correct thing, it will be rewarded. When you are doing a wrong thing, it will be punished. I mean, certain loss will be calculated according to this part. The machine will learn by itself to provide a accurate answer to it. Okay, so this is the thing called what we call reinforcement learning part. So this is the final machine learning, how it works. You are having a data, and what is the concept behind that? You are going to develop a model. So this model will train for n number of features, that is 80 to 20 phase. After that only it will come for a line. So don't think you have trained a certain model, you can directly go for simulation. But the machine is designed in such a way, even it is trained, 80% of the data will be taken for the training, and 20% of the data will be taken for the analysis part. After doing this test and analysis, if something is not good, again the model will be refined, then only it will come for the live session. This is how it has been designed for the final implementation of machine learning algorithms. Okay, there are n number of applications are available, you can't even count. There are a few applications I have been listed out here. What is the first one? That is sentimental analysis. You see here, I have n number of tweets from, I want to gather the feedback analysis of my particular product. I can gather from Google or app like Amazon, Flipkart, whatever the online stores are available on general Google. I'm getting all the tweets as the input. What is the tweets I have taken? I lost weights and bias, great visualization. So like that, I am getting a certain word. How I can do a sentimental analysis is, I will take the input words like love, great, wow, I wish to, wow, wonder, I impressed. All those words I can use when I am feeling a positive way. Definitely when I'm feeling a negative way, I won't use such a words, right? I will use hated, I don't like, it is a pathetic, I literally frustrated, like that words only I will use for the negative purpose. So by keeping that words as the keyword, I'm just classifying my feedback as the positive and negative feedback. You see here, see sometimes that's why I told it is a prediction. You know, sometimes it may, even though it is a negative, but the people are, some people know how to give a negative feedback also in a different way, right? If you're giving such kind of tactical word in your feedback, your machine can't understand because it is not intelligent enough.
பரவாயில்ல அனுப்புறேன் கவனி. ஒரு நாள் இல்ல, ஒரே ஒரு மணி நேரம் தான்.
Can you please mute?
ஒரு நாளைக்கு ஒரே மணி நேரம், 10ல இருந்து 11 வரைக்கும்.
Sir, may I know who's that? Can you please mute, madam?
Please mute your mic, sir.
Okay, thank you. So based upon that thing, you can classify whether it is a positive feedback or negative feedback. Okay, so this is called sentimental analysis. I told already, if you're using any word trick to give you a feedback, that can't be predicted by the machine. You are giving a direct feedback like with a positive note or negative note, it can be identified by the machine learning. So I told, right, because it is just a machine, what it has been learned for, that only it will be predict, not more than that. So the next one is product recommendation. So this is one we are experiencing in our day-to-day life. If you are going for a Amazon purchase, for example, Great Indian Sale is coming, right? If you are going for a certain thing, I'm going to purchase a certain mobile from the Amazon. When I'm booking my product in add to cart, while about to move a cart, it will give you all suggestions like the people, those who bought mobile, they have purchased the back cover and what is the temper glass together. Do you want to add? How it is asking? Because it is learning from the past. If suppose 1,000 people ordered mobile, all those people, it is a basic minimum. Once you are buying a mobile, you should buy a back cover and the temper glass. It is a safety measure. So that's why your software is recommending you, like already purchased people bought that. If you want, you can add. So this is a kind of increasing their selling through the machine learning approach. Okay, and similarly, once you bought some toy for kids, next time when offer is coming or some other product came or something it's happening, it's keep on reminding you. You have based upon your past purchase, I'm recommending all those items to you. Do you want to purchase? Do you want to purchase? It's keep on asking us why, how it is possible, because by reading your past history of purchase, it will recommend you what kind of product you may like in future. Okay, so this is called as machine learning process. I told n number of applications. These are the few applications related to the machine learning part. Okay, so you can implement machine learning using various languages, Python, R, C++, Java, JavaScript. But one of the most famous language is Python. Why? Because it's a library. You are having a number of ways behind why you are choosing Python. But the most famous and the most important thing why we are choosing Python is all those features involved in it. Okay, these are the famous machine learning libraries that involved in implementation of machine learning, which will make implementing the machine learning is the very easiest one. Okay, because everything come as the ready-made one. You need not to do anything. It's like 2 minutes noodle, you can prepare anything, right? Like that, these are the essential Python libraries which will make our scientific process as the very simplest one. Okay, so what are the things? NumPy, SciPy, Scikit, Matplot library, Pandas, and TensorFlow, Keras. These two are exclusively involved in the neural network part. Okay, it's normal Python machine learning things don't need of Keras and TensorFlow, but the neural network concepts is much need the TensorFlow and Keras concept, because all the predefined library things are already available in that particular package. There are many ways to implement your ML. The most famous thing is Anaconda, Google Colab, and Kaggle, right? You know how to install Anaconda. It is a kind of package. It is a completely open source. You can download from the net. It have n number of things in it: Jupyter Notebook and RTool, Python, PyChamp, like that. N number of tools are coming as the free of cost. You can download and install with it. So this is the procedure how we can install. It's very easiest way to install. That in Anaconda homepage, if you go, you can download and use as per your machine, Windows or Mac or Linux. You can download and install it. You can directly open Anaconda prompt and you can execute your Python code. So that is the machine oriented. Suppose your machine is not having that much capability to run Anaconda, your storage and RAM capacities are not sufficient, you can go with the Google Colab, right? Like Google Drive and Google Photos. The Google Colab come with the free of cost with the Google account itself, right? Hope everyone have, since all are faculty members, you may have already experience with how to execute with the Google Colab, right? Even if it is not, when next sessions will be handled with the hands-on, on that case they will show you how to connect with the Google Colab. So what is Google Colab now? Google has exclusively given only for executing this Jupyter Notebook environment for Python. Some people don't have capacity to execute their programs in their computer. The Google is providing chance to them, the RAM capacity and the hard disk allocation, everything it will be automatically doing. You know what is the power of Google Colab? If I want to tell, it is at the beginning it will be allocated with the CPU. Okay, tens of operations per cycle you can do. But if you are increasing your complexity of your coding, for example, you are executing something related to the neural network, the CPU will be changed to GPU, that is graphics processing unit, tens of hundreds of operations per cycle. But I never used a TPU, because when you are doing that much complicated operations, by default your account will switch over to TPU. So 1,28,000 operations per circle it will do. Then you imagine how much fast it will work with the things. Okay, so this is the importance of Google Colab. Then these are the some of the websites where you can find the materials for learning the Google Colabs. Is there any doubt in machine learning? You can ask, else we will move to the neural network concept. Is there any doubt? So any queries if we got in chat box, let me know.
Am I audible? Yes,
Yeah.
Dr. Nitya. Yeah. Yes, ma'am. I have a query here.
Yeah.
Like you told about Google Colab, right? Yes, when we are processing some programs, we are saving enormous data sets, right? So
Yeah.
while we are calling that URL from Google Colab, sometimes we are getting this storage issue,
Ma'am, that na
right? Yeah.
like I okay.
Yeah, even if we select like GPU, whatever you told, we are going for thousands per cycle also, though we are getting some issues. So it's very tough for us to execute.
Okay.
You get my point, madam? Yeah.
Yeah.
Yeah, in that case, is there any other tool which supports large storage space?
See, ma'am, no one will give everything for a free of cost, right?
Yeah, no, not free of cost, but anyhow,
Yeah.
we have access with some data sets, even then for simple data sets which doesn't have large storage capacity, also we are getting some issues
No, ma'am.
in
Depends
running that
on your
particular
memory
data set.
capacity also. If you're having already too much of data, it may get struggle. Better
So
you.
commercial tools only is the only option, right?
Yeah, ma'am.
Yes, ma'am. Thank you.
Okay.
Proceed.
Okay, ma'am. Thank you. So the next thing. So shall we start? Is there any other queries? Okay, fine. Next, we shall start with the neural network. So this is a continuation of previous thing only. So I told already, like when you want to go in depth of analysis, the machine learning will not work. I can't tell it not work. It will work, but the precision what we are expecting from the prediction will not be that much good. If it are 80% of good prediction, if it is doing now, if you are using neural network, it may go up to 90%. So this is why we are came up with the concept called neural network. The best example I told, handwriting recognition. Okay, 1 second, I will try to annotate pointer options. Okay, so here first we will see the difference between, I told I will show you in the next session, right? So this is how the exam difference lies. Machine learning, first I am giving a certain car as the input. Here what it will check, first how many wheels are there, what is the length, what is the height, what is the width, all those things. So these are the simple features I am telling. As a user, I will see 4 wheels are there, definitely it should be a car. See, if it is a bus and all, it may have a 6 wheels, so definitely it can't be a. So based upon a wheels, and not only a wheel, I can check. I can take other features also, like what is the length, what is the height, all those things I will extract it as a feature, and I will do a simple classification. I will come to a part like whether it is a car or not car. That's it. Okay. So I will take input in the first layer. I will provide output at the last layer. In between one, what we can tell, I can do a mapping, and I will come to a final conclusion. This is called machine learning. It don't have multiple hidden layers. Only one hidden layer will be there. That will transform my input to output part. This is called machine learning. That's what we have discussed so far. When you are coming with the deep learning, okay, here just there is no one sit here to extract the feature and all. Here I will extract the features like this. Okay, what I will do is I will do a n number of hidden layers before I am coming to a final conclusion. You can see, first I will make a certain combined model, that again these features are going to be combined into combined model. Again, that combined model is checking for some other feasibility. After that, I will come to a conclusion whether it is a car or not. So what will happen on that case, I may get 100%, as I told, sorry, I can get 95% of more acute output than the machine learning concept. So that's how the deep learning comes into the picture of machine learning, comes into the picture actually. Rather than machine learning, deep learning coming into that position only. Okay, so hope you are clear why we are moving with the deep learning. It's not a one hidden layer. It includes with the n number of hidden layers. It depends upon your complexity of the problem. The number of hidden layers will be increased to produce the most accurate answer. Okay, so if you see what is deep learning and neural network, no? Deep learning is the part of artificial intelligence function which will imitate a human brain in processing of data that creates a patterns for use in a decision making. Why you are using, ma'am, human brain now? Because the deep learning is mostly the most important thing is that is neural network. See, on that case, neural network, it is a part of our, you can tell, heart of the brain. right? If it is not, the brain is working full of neurons is working, right? So the same thing they are imitating here. If you see the most of the things like that to bio-inspired algorithms and all, if you are saying it's completely how our biological systems is working, they have imitated the same thing in an algorithm basis. That's how it is working. Okay, so the same thing happened here. Deep learning is a subset of machine learning in artificial intelligence that has networks capable of learning unsupervised data that is unstructured or unlabeled. You have seen, right? While I'm discussing, I told neural network as an example. I told, don't worry, we will see it in next slide. This is how it came. Okay, the deep learning AI is able to learn without human supervision. Okay, the data may be unstructured and unlabeled. It is going to learn from them. Okay, so here deep learning is mainly implemented using the neural network concept. So which will 100% it mimicking the human brain concept. How the human brain is working, the same concept dittoli they have been mimicked in the neural network concept as well. Okay, you may have a doubt, right? How it is working. It is taking whatever the input it is taking individual neurons it will take. There are n number of inputs. What are the attributes you are separating here, right? Whatever the feature you are extracting, each and every feature is considered as one input. Okay, that one input is assigned to one neuron. That neuron, this is the input layer. Finally, I want the output whether it is a car or not car. That's it. Here features and all mapped in neuron. What it is going to do, it is going to do a multiple kind of permutations among them and to find which one is giving the highest correlation to get my final output. Okay, so each and every neuron is provided with some weight, that is nothing but how much it is supporting whether the particular node is correct or not. So that is the where it is given with the weight 1 and weight 2. Like that, each and every neuron is provided with the weights. So what is the possibility of occurring with the right or wrong? So that part is called as weight 1 and weight 2. Okay, so this is how it will be done with the layers of neural network structure. So before that, I just want to explain you how the neuron is structured in our process. You see here, this is our computational model. This is our biological model. Hope this we have studied during our inter, I think, right? This is the thing. What it will do, Detroits is nothing but input, you know, right? The input output of one neuron will be taken as the input for another neuron. So likewise, it is also coming from another neuron. Okay, dendroids are taking as the input of the neuron. Okay, it will be processed to the nucleus and it is passed to the axon, and finally the axon terminals will connect it to the another dendroids of another neuron, so that whatever I processed in this neuron, it will be passed to the another neuron. Okay, this is how it has been connected in a natural way, biological neuron. But this is our mathematical neuron. What we will do is axon from another neuron. So that is nothing but what is the input I got it from another neuron will be called it as the X0. Synapse now, the synapse is nothing but it is a point, okay, where I'm connecting the previous neuron to the current neuron. That is called synapse actually. So synapse is the point where I can connect my previous neuron to the current neuron part. Okay, then what else? What is the weight allotted to this particular point, and that will be multiplied with the already received input. So that is how it got weight of the current dendrite and what is the axon I received from the previous side. So that is how it is called W0 into X0. So the one neuron I'm receiving from the previous state, that is going to be connected to the current cell body. Okay, how I can do it? Summation of all weight and previous neuron plus it is added with the bias value. So all these things will be given to the activation function. Finally, I will get what is the output axon. You don't worry about these terminologies and all. We will explain all those things in our later slide. So this is how one what we call one neuron is working in your mathematical model. It is 100% mimicking your biological neuron structure. You see here biological neural network and artificial neural network. Soma means biological term, but here we are calling it as the neuron. Dendrites are the input in our biological. Here we are calling the term as input. Axon as the output of biological neural network. Here we are calling the term as output itself. Synapse, na, you know, right? In biological term, it is called as the point. The previous neuron is connecting with the current neuron. So here I can calculate it as the weight. So right, because that weight only I am multiplying with the earliest one, right? So that is called as the weight here. So this is how your biological neuron and this mathematical neuron is getting connected. Okay, you see here, this is the one neuron I have done a zooming. What we have done, one neuron is there, it is giving an input to another neuron. What it is doing, it is taking an input and weights what all it receiving, plus it is doing a bias function. All these things will be supplied to the activation function and it will work for the next thing, right? This is how it has been connected for. So you see here what happened now, in this part how it is working. There are four major parts are there. First one, what is input? Input is nothing but a set of data that I am receiving from the previous one. Whatever the previous neuron may be, that features you can consider the input as the attribute or feature that you are getting from the previous data set will be considered here. Sorry. What is the vector of weights? Here weights are the real values. What will happen here is each and every state is connected to some number that conveyed to that the corresponding value is the final output that will decide the neuron and the next part. That is called vector of weight. Then this is the bias. The third one, it is nothing but you want to shift your activation function towards a certain left or right to make it as the whole value, right? So to that part, I can add bias as the one part. Okay. The next one is the activation function. So here the summation function is there, right? Input star weights plus bias. It is a kind of the total summation of how the neuron is getting connected to the previous input, how it is supporting for the further calculation. All those things will be done over there. Then last one is nothing but activation function. What is my activation function? It is nothing but one mathematical function to do a complete transmission of this output to a which is ready for giving to the next layer. Okay, so that is called as the activation function. You see here a neuron computes the weight of summed input in such way y is equal to sum of weight star input plus the bias value. Okay, hope you understand what is the meaning of each and every terminology used in this part. So this is how it has been connected. You see here, this is one just one simulation model, how it works. Okay, in this particular neuron, I am getting input from the various neurons. One with the 0.7, one with the 0.6, one is the 0.4. All are doing a sum, right? Somehow it will do 0.7 plus star previous value plus 0.6 into previous value plus 1.4 into previous value. All those things it will do and it will find the summation of it. The finally it will be added with the bias value. Then it is forward to the bias, activation function. From activation function, I will get ready to give the output of this particular neuron. It will be given to the next session. Right? You got it how it is working now? So this is how it will work. Then deep neural network, this is how it will work. So don't get confused with the word deep neural network. All are meaning same. You don't have any difference. Okay, so here is one example how it is working and all. Okay, you are telling attribute features how it will divide and all. You see, I told already 8 is an example, right? I can put 8 like this, I can put 8 like this, and I can put 8 like this. So because it is a handwriting, depends upon the person, it may differ. You can't tell the 8 should be always like this. So how I can recognize it? You see, it is not closed. I can't come to conclusion whether it is a 8 or not. Some people may write perfectly like closing this also. How I can do that? First I will do is I will divide my entire pages into a small pixels. You know, right? Pixel is the smallest unit of any image. Hope you have seen, right? That pixel I will divide. For example, I have divided this into 784 pixels. This particular input, I divided into 784 pixels. So what I will do in this part is each and every, already you see, right? Each and every pixel I assign to one neuron. So these are all one neuron. What I will do, I will search all the combinations. You can, it is showing only one hidden layer, right? But it is not like that. It is the first layer. This is the second layer, third layer, and finally there will be a conclusion 0 to 9. One number will be there. Among that, it's going to be a one number. How it is going to do? It is going to combine two cells together. It will find, and finally by combining all the things which is having the highest correlation. For example, definitely a 6 can't be like this, correct now? If you are checking that particular number mostly related to which number it is coming, that will be predicted as okay, 8 or 7 or which is highestly correlated with that image, that will be taken as the final output. This is how your neural network is working literally. But how inside it is working and all, it is depends on the previous one. How much weight it is getting, whether it is strongly supporting or lightly supporting, all those things will be taken into consideration. You see here, this is how it will work. I have given 2 images. For example, this image I have given, it will divide it into each pixel. One pixel is assigned to one neuron. Then it will find all the combination. You see here, each and everything is connected to each other. Again, I'm telling this is a hidden layer. Hidden can be having a n number of layers. It's not a single hidden layer because it is a neural network. It may have a n number of layers in it. It's not only one layer. But as of our vision, it is showing a hidden layer because inside hidden, what is happening, they don't want to reveal to us. That's why it has been given in such a way. Hope I am clear to you, right? How the neural network is working on. Finally, which is having the highest possibility, that will be derived as the animal name. Okay, so this is also a kind of thing how we are doing here. This is a input. The image is broken into pixels. Okay, that pixels is assigned here. The each and every assignment is known as individual neural network node. Then after that, it will combine the edges to find the features, and finally it will come up with a certain thing which are all having the highest feasibility, which knows that when these features are matched, definitely this should be the features of dogs, so that I am concluding the given creature is the dog. So this is how your neural network is working. So that's the place the weights are playing a major role. So if that particular feature is matching, you can give the weight 1 or 0, -1, like that, anything you can give. It's not always the weight will be from -1 to +1, we will provide the thing. So accordingly, that will take strongly agree or not at all supporting or strongly disagreeing, like that it will calculate the things. Okay, one example I'm going to show you the demo, so which will make you to understand how these things are happening in your part. Like I'm telling you how the weights are assigning, all those things that we are going to discuss here. You see, this is 1 pixel. Sorry, this is a 4 pixel part. Here I am going to take this 4 pixel camera. This 4 pixel camera, I just want to come to a certain conclusion, which one is the strongly, which one is not, and which one is the, whether I have to consider the pixel or not, how I am coming to a conclusion. That's what we are going to see here. You see, this particular part, if it is a full black, I can come to the point -1. If it is a full white, I can come to the part +1. Okay, so in between I am just dividing the pixels in a various ways, like light gray, little bit lesser than black, and lesser, and 0 is the moderate color between the white and black, and almost white. So towards white and towards black. So towards black will be a minus value, towards value will be a plus value. Actually, this is how it has been assigned, a mathematical calculation behind that. This is how the nodes are provided with the values as well. Okay, here what I am doing, I am just dividing the pixels into one neuron. This is how it is happening, right? Each and every pixel is assigned to 1 neuron, I told. So 4 pixels camera, that's why 4 neurons are assigned. Here I am assigning value for the neurons. How I am assigning? If it is a moderate between black and white, it should be a 0.5. Okay, and it is almost towards white, so that 0.5. It is in between black and white, so 0.0. It's almost nearer to black, so -0.75. Here it's almost nearer to white, but not completely white, so that I'm giving a value as 0.75. Hope you're clear how the weights are assigned to my neurons. Okay, depends upon the, because it is how it is happening in our process as well. Now what is happening? Now I have assigned a value to these things. Okay, here randomly we are assigning a weights to my path. So it is a -2 star. Here it is a 0.8. You can see the difference, right? When it is a very strong, always white will be plus, negative will be minus, right? The thickness indicates how much strongly it is associated with that. So one is 0.8, it's almost reaching 1. So the thickness of the line is very high. It's almost reaching black, so 0.5. It is very light, so it is a minus 0.2. So what we are doing as per this thing, what I can do is, what is the value of previous neuron multiplied with weight. These are the randomly assigned weights, how much it is supporting for the final contribution. Okay, 0, once it is a 0, anyway it is a multiplication process, I need not to assign a value for it. Even if I assign, nothing will give a meaning, right? It will not have any connection. Okay, so that 0.5, that is a neuron value, is multiplied with the current weight plus the neuron value into weight plus neuron value into weight. What I am getting? I am getting the value around minus 1.705. Okay, so this is the value I got it. But see, I don't want to, when I am getting something like this, I can't predict to the next layer. So what I want to do, so before I am applying this to the next layer, so before I am giving this function to the next layer, I just want to do some kind of mathematical function, so that I want to keep my value from 0 to 1 only. So that if it is a 0, that is not, if it is a 1, it is a, it is 100%, it is going to be a dog. 0, no, it's not a dog. Like that, I want to give a data in a 0 or 1. On that case, if I am getting a value like this, it won't work. So for this purpose only, we are having something called bias and activation functions and all. Why we are doing that? This is why we are doing that. Okay. Before we are doing that, there is one thing called sigmoid squashing function. This is a kind of most important function that they use it to do in a neural network. You know what they will do? It will apply it in an activation function. We have used something as f, right? Activation function. The sigmoid function is the most important thing to do in that part. What it will do, whatever the value you give, even you can give the number in any infinity, it don't mind, it will take the number from 0 to 1 only. Like that, it will do a transition in that part. It is a completely a mathematical model. It includes a n number of property, like you can give the input from minus infinity to infinity, it don't mind. It will give you the final output as what we can tell is monotonically increasing way, so that it will goes only in 0 to 1 in that way. So likewise, it will make the things in a normalized way to give the output. So why it is that much important? As I suggested already, you are going to guarantee that your final outcome of each and every neuron will be always in between zeros and 1 only. It's not going beyond much, because you are doing a weighted sum, right? There is a possibility it may go beyond the function. So that what I'm going to do, by applying sigmoid function, I'm going to consider it as the, what we can tell, value from 0 to 1. So what it means, 0.7, it's almost supporting to my positive correlation, right? Likewise, it will be done. This is called as the sigmoid squashing function. Okay, hope I am clear here what I have done. So the next part is nothing but weights will be, so this is the nothing but weights will be considered plus 1 na white, minus 1 na black, 0 na missing part. So that is how already we are doing. So here after this, whenever white line is coming, it is nothing but it is supporting white part, and minus is minus 1, sorry, white na plus 1. Okay, when I am showing a black line, it knows that it is a minus line. Okay, if nothing is there, nothing will be there, 0 will be there. Why I am telling, I just want to find the different patterns behind it. For that only I am just showing here. Okay, now what we will do, you see here, this is a pixel, I have been taken a certain value. So what it means, it is going to be only this part will be activated one. If you go this, only this part will be activated. In this part only this part is activated, and this part is activated. Right? So this is how it has been assigned. Now let us check. If you are going to combine these two features, so what will happen? These two features, what will happen? These two features, what will happen? Like that, this is called hidden layers. So first I am assigning each and every pixel to each and every neuron involved in this process. Okay. Once neurons are assigned, I want to find the correlation between the each and every pixel assigned in the neural network. What I will do, I will take these two combinations. Okay, this mode and this node I am taking, both are in a white color. So what will do, I will take these two things will be in a positive connected way. These two are not at all connected. So likewise, I will combine each and every part involved in my pixels. So the 4 pixels are combined in many ways. Now, okay, now let us come to the next part. Now what I am doing here, what I will do is these white part is taken here, this white part is taken here. You see both are white lines, so that I have taken everything is the white color weighted component. You see here what I am doing in this part, the first half, I mean the first half of the thing is I am considering in a negative way. So here it is a -1. Here these two things I am taking in a, sorry, this connection I am taking in a white. So this is considered in a +1. Okay, wow. So like that, I am taking into consideration of the pixels. So what is that black? What is the white? Hope you understand. Accordingly, I am doing. Ma'am, what you are trying to do, we don't understand. Now. I'm just trying to find the different patterns behind this 4 pixel camera. Okay, you see here, I keep on applying a sigmoid function to find the different properties among them and different varieties among them. I just want to find whether yes or no. Okay, among this thing, I just want to find whether it is a diagonal shape or it is a, so I will show you in the next slide. Okay, what I'm trying to do. What I'm doing again, now this perfect square I got, in this perfect square, it can be either white. So what it means, it completely supporting, or it can be not supporting -1. If you take in this way, it will be taking -1 +1 concept. If I am giving a negative way, positive will be negative will be given positive and positive will be given negative, because it is connected in a reverse way, right? So that it will be likewise. It is also one diagonal, another diagonal, and one horizontal, another horizontal. What will happen if I am connecting with a white node? It will be coming as it is. Hope you understood, right? White is nothing but +1. If you are multiplying anything with the +1, what will happen? +1 will come. If you are multiplying anything with the -1, the opposite direction will go, right? That's what it's happening here. Here, what I'm doing is, I just want to do a final rectified linear unit. You know, here, what is final rectifier linear unit now? So this is a kind of linear function. Why we are using that? I just, you see in previous session also, I am taking the value from -1 to +1. But what I told you, you should give always, my final output should be in a plus or, sorry, 0 to 1 only. But I can't make all the string attested to 0 to 1, right? So that we are applying some sigmoid function as the activation function to deliver, to make my things between the -1 to +1. Now I am using certain rectified linear activation function, or it is called as the RELU. What it will do is, it will do a function as just 0 to x. What it means, whatever the number is, whenever your number is positive, you can keep as it is, because already I normalized my value from -1 to +1, right? So here what I want to do, when I am having the number from 0 to 1, whatever the value it may be, that value I can keep as it is. For example, 0.76. Okay, I can keep as it is. Suppose some value is not 0, not positive. What it means, 0 to -1, any value it may be, you simply make it as 0. This is the core concept of rectified linear unit. If I want to take class about this one, you can take minimum 2 hours class in this itself, but we don't want to enter that much depth in it. We are just telling how this is working. Okay, what I have done, so I have taken the value from 0 to minus, whatever the other than positive value, whatever I am getting, you just make it as a 0. Like that, what I am telling you, see here, everything will be 0. After plus, whatever the value is that will goes in value, goes in a positive way. Since already we have blocked, I mean, already we have corrected this value from -1 to +1. So there is no need to worry about the final outcome. Okay, so this is how it's happening. You see here, finally, what is happening? Either it is a fully black or 0. This one is 0, right? Whatever it may be, this is nothing but a solid pattern. This is nothing but a vertical pattern. And this is nothing but a diagonal pattern. And this is nothing but a horizontal pattern. So I can easily find these kind of patterns from my 4 pixel. Now, if you consider this is my final input, this belongs to the model of horizontal. How it is possible? It will check each and every pixel. Okay, hope you are understood how we have done. This is 1 pixel and this is another pixel and this is 1 pixel. Like that, I have divided the things. Now, by splitting the pixels and finding all the combinations among them, I can come to a conclusion. The given pixel is in the horizontal pattern. I can come to the conclusion how I came. This much travel I have done to calculate this particular path. First, each and every pixel I have assigned to a neural net, one neuron. That neuron is assigned with a certain way, a certain value. That value is again multiplied with each and every weight, how much it is strongly agreeing that particular process. Accordingly, I am doing. After doing that, each and everything is passed with the multiple sigma activation functions to deliver my output in between 0 to 1. After that, it is finding all the probability and coming to a conclusion what are the different patterns. Finally, it is showing this many kind of outputs are available, but my given pattern is mostly accurate with this part, so that I am coming to a conclusion the given camera pixel is showing the horizontal network of pattern or horizontal patterned image. Like that, I can come to a conclusion. So this is how one neural network concept is literally executing in our neural network concept. Depends upon the application, it may vary, but the thing is the mathematical concept behind the neural network is works in this way only. Okay, va? Hope I am clear how it is works. Then there are n number of neural network types are available. That is nothing but convolution neural network, recurrent neural network, feed forward neural network, multi-layer perception, radial basis new function neural network, modular neural network, sequence to sequence. See, these are the n number of models that you have used in CNN, RNN, right? All those things are the most famous neural network concepts. If you say how I can implement neural network, you can implement using Anaconda or Google Colab. And language is most familiar language for neural network is you can go with only Python. Why? Because when you are entering into neural network, there are n number of features involved in it. If you are doing coding for each and everything, it's not possible to complete at all. But if you see in Python, all these things are ready-madely available. Only thing you should know how to import that module in our package. If you know that part, by default, you can execute all those things very easily. So I think TensorFlow and Keras are involved in our further classes. The next sessions, experts will handle all those things. Okay, then where we are using this part now, speech recognition, image processing, music composition, handwriting recognition, you see all are very complicated things. It's not that much easy to understand the things. If you want to recognize the speech, if I am talking, I use it to feed my things, but someone else is talking like me, there is a possibility the voice note may be possible. So what I want to do is, it's not that much easy to understand the thing by computer. So how much you want to do? You want to take every individual part, individual note you have to consider, then only you can come to a highest precision data. Else also you can, but there is a possibility the accuracy will not be there. So to improve the accuracy only, we are playing the major role with that neural network part. Okay, so that's all. Is there any doubt? You can please ask me. Thank you. Is there any doubt? Is so if you have no doubt, I can ask our coordinators to conclude the session. Okay.
Thank you.
Jagadish,
Thank you very much, madam, for your wonderful session.
thank you, sir.
Dear participants, is there any doubts? You can ask any doubts. Otherwise, we can wind up the session now. And then one more thing, I will share the feedback link for this current session now.
Thank you, madam.
Thank you, sir.
Thank you.
Dear participants,
Jayanti ma'am.
evening as usual, 6 to 7:30.
Thank you, participants, for your wonderful listening. And someone asked question. I don't know who's that. And thank you, coordinator Dr. Jagadeesan sir, and Gurunathan sir, and Anandraj sir. Thank you.
Thank you, ma'am. Thank you for accepting this invitation also. Thank you.
Yeah, it's my pleasure. Bye, sir.
Thank you. Dear participants, now I have shared the feedback link. Only fill this form.
Sir, whether it is available in WhatsApp group, sir?
Yes, madam. I will later. I will forward this feedback link into WhatsApp group also.
Okay, sir. Thank you.
Okay. Thank you.
அது ஃபர்ஸ்ட் எக்ஸாம் நிறைய நல்லி வந்துச்சா கொஸ்டின் பேப்பர் ஈஸியா